This is lesson 6.4, and this is on the Pythagorean theorem. The Pythagorean theorem states that for a right angle triangle, the square of the hypotenuse is equal to the sum of the squares of each side. The hypotenuse is always the longest side of a right angle triangle and is directly across from the 90-degree angle. The formula for Pythagorean theorem is a squared plus b squared equals c squared. So what's that mean? That means if we have a right angle triangle, we got A, B, and C. If we square both of these sides and add them up, they should equal this side squared. That's how Pythagorean theorem works. So we can use this idea to solve some sides in triangles if we know two sides, specifically if it's a right angle triangle. To do that, we're going to label every side. C is always the hypotenuse, it's the longest side. The A and B are called the legs, the two shorter sides, and it doesn't matter which one you call A and which one you call B. C is the one that matters. Step 2, substitute the values that we know. We should know 2 of the sides. So either A and B to find C, or maybe B and C to find A. And then finally rearrange the equation and solve for the side we don't know. So we're going to do two examples. One where we're going to solve for the long side, and one where we're going to solve for a leg. First example is finding the hypotenuse. So we're going to first label each side. So the long side is C, which would make this side A and this side B. Now we could switch them. We could call this B and that A, and we'd still be okay. It's just that C has to be across from the 90. That means it's the side not touching the 90. So now we write Pythagorean theorem, a squared plus b squared equals c squared. Fill in what we know. We know A is 3, so we got 3 squared. We know B is 5, so we got 5 squared, and we don't know C squared. Now we can do a little bit of math. 3 squared is 9. 5 squared is 25. Remember, squared just means times itself, so 3 times 3 is 9. 5 times 5 is 25. And that's going to equal C squared. If we add these up, we get 34. So C squared is 34. One more step, because we don't want to know what C squared is, we want to know what C is. To find C, we just square root 34. If we square root 34, we get, on a calculator, have to know where our square root button is. Mine's right here. And we're going to square root 34. And I get 5.8 centimeters. There we go, that's using the Pythagorean theorem. So this can get a little trickier if you're asked to find one of the legs. So let's label the triangle first. We've got the side across from 90 this time, so that's C. And we're going to call this side A, so we don't know B. So if we write Pythagorean theorem, a squared plus b squared equals c squared, and we plug in what we know, this is what happens. 4 squared, because A is 4. We don't know B. We do know C, 8 squared. And now if we square those numbers, 4 squared is 16, and 8 squared is 64. We don't have the letter by itself, which is what we want if we're trying to solve. So to get the letter by itself, we have to move the 16 to the other side. And we end up with b squared, letter by itself, 64. And when we move a number across the equal sign, we use the opposite. So instead of plus 64, it becomes minus 64. And now we can solve for b. b squared is 64 minus 16, which is 48. And our last step of Pythagorean theorem is always going to be to square root, because we want the letter by itself. Square root 48 is 6.9. And we're centimeters again. All right, that's actually it for lesson 6.4, Pythagorean theorem. Just remember the two different examples. If you're asked to solve for the hypotenuse, we need to model it like this example, where we don't need to move anything, we just need to do the 4 steps. If we're solving for one of the short sides, the leg, we're going to have to move the other side over to get the leg by itself. All right, thanks for watching lesson 6.4, and I'll see you next time.